Hello, today's video will be more like a walk down the memory lane. I hope for some of you it will be interesting. And first of all, let me tell you a bit about what you are seeing in front of you. It's a schematics of a 1964, I think, television set. I have to say that I have only basic electronics knowledge, but I have experienced in the past some televisions using valves or electronic tubes, and there are some interesting aspects to consider when looking at them compared with modern times. And this is the main reason I would like to show you these details that are very far away from the present. So let's start by mentioning a bit what we are seeing in front of us. First of all, we have a television set that was monochrome. So of course you don't have to have very high expectations, and I have to give you the name of the TV set, but this is not going to be very helpful. First of all, because the TV set was not made in the West, in the American or German, Spanish, French areas or countries, to be more specific, sorry. It was a TV set made in Central Europe, so you're going to have a very difficult time finding some aspects that would make it fit the present time or try to make a connection. And I am well aware of that. However, I would like to mention some aspects that are very interesting. I'm pretty sure that this TV set was inspired by a Western model, and I'm entirely sure because this was the tendency back then and also up until the end of the communist regime in most of Central and Eastern European countries in 1989 or 1991, because in 1991 it was the end of the Soviet Union. And before, there were a set of revolutions in most countries like Poland, Czechoslovakia, Romania, and others. So I would like to begin by mentioning some details that are highly interesting. First of all, you have to think about the context of electronics in 1960s. We didn't have transistors, we didn't have integrated circuits, so just about everything pertaining to a radio or a TV set was in some ways more complex and also more relying on constant maintenance in order to work. You have to think about the fact that you would have electronic tubes that would fail after some 1,000 hours, and some 1,000 hours didn't mean too much. You have to understand that they would also fail prematurely, and there were instances when you would not have a chance of seeing such devices for a long time working reliably, because there were so many things that would go wrong. Part stability was not great. There were various issues that occurred when the device was being used, and due to the high number of components and especially of electronic tubes, you would have to understand that reliability was very difficult. And of course you have to think about some decades where the technology was in its nascent stages, so there were less ways in which some issues were corrected as evolution and experience proved later. So you have to understand the context that some of these complex solutions were later abandoned or were later integrated, which actually got to be what happened in the present time. So let's look at them, and with my limited understanding, let me show you some of these details. So first of all, I will start with the picture tube. You have to understand the fact that cathode ray tubes back then were not overly reliable. There were a couple of reasons why this happened, and the most obvious one pertains to the filament and most likely the cathode. Emissive surfaces didn't have a very long lifespan, and this meant that the performance of the tube was degrading in hundreds of hours, and even before the mark of 1000 hour, the tube already was showing some weakness in having a good contrast on the image and showing enough brightness. So the picture tube was the first element that would fail gradually. Actually, it would be worn off. It would never fail spectacularly, but it was a component that was constantly degrading. Another very important aspect was that a picture tube was extremely expensive. Replacing a picture tube, you have to understand that you would do something similar to replacing the engine in your car. So it would be prohibitively expensive. It was just as buying a new TV set in most situations, because very few were manufactured. They were manufactured for a specific class of products, and this meant that a picture tube for a couple of TV models was not necessarily directly compatible with others. So there were so many other things that could go wrong, or that had to be adjusted in order to work properly. So the cathode ray tube was the first element that you would see gradually failing, although you would not notice that, and sometimes you would think that there were some other components that would fail. But of course, in most situations, the picture tube was not the one to have an immediate failure. It was one of the tubes that were in the circuit, or one of the capacitors or other component that was being stressed and blown up by a short circuit or something that went wrong. So you have to understand that the picture tube was the most important, but there were many other components that would fail, and they would fail regularly, probably every couple of hours in use. So it was a totally different situation from what we see today, with a TV set that could be used thousands of hours without any sort of intervention from the user. In this case, you would have to at least be accustomed to what was happening in television sets. So being a user was not a situation you would be that would be similar to what we have today, meaning that you would just start a device and then stop it, and that was just about it. Because maintaining a TV set was expensive, you should know at least about some components and be aware when it's time to replace them. So, okay, this is the context. So TV sets were overly expensive. Think about thousands of dollars, similar to the price of computers, of expensive computers today. Very few persons had a TV set back in the 60s and even early 70s, because the price was prohibitive. And color TV sets, when they came, they had an even higher price. So you have to consider all of these aspects. The TV market actually started after the Second World War, and had a serious run up in the early 60s, because it was also the situation that many TV channels appeared. Most countries had at least one national TV channel, and the broadcasts were actually opening a new world to most of us. So in the 60s, you would had to have you would be required to have a TV set, but it was something that most people didn't have the means back then. So some years passed, but it was a very fast transition. You have to understand the fact that before the early 1970s, most persons at least had a TV set, or they had a TV set at one of their relatives or friends, so they could see some let's say TV transmissions, not necessarily TV shows, because you have to understand that most of the things that were presented, were broadcasted, were mainly news programs and some live TV shows. Later, of course, recording, tape recording was possible. Even showing some movies was possible. So before the early 1970s, a whole array of TV broadcasts were possible with the current technology, using TV film and so many other ways in which the image was being recorded. But early on, it was just film and live shows. Recording was not possible. So about this TV set. Well, the most obvious fact you're going to notice, and I will present to you things as far as I could understand, because I was interested in these TV sets. I even grew up with a tube TV set. It wasn't a full tube TV set, it was a hybrid one, but I also noticed I used a full tube TV set. Hybrid ones were TV sets that were built later, around the first half of the 1970s, that had tubes and transistors. Parts of the circuit were being built built with tubes. Parts were built with semiconductors. But even before, there were some components that were inserted in the schematics that actually made it possible to have some sort of better integration and less component bill of materials, and of course less complexity. So first of all, let's think about the beginning. The TV set is powered at 220 volts. Of course, there were sets that were released on the market worldwide that were powered at 100 volt, 120 volts, 240 volts. There were different mains voltages used in various countries, but this meant that it was sometimes a very big problem when trying to power a TV set in another country having a different mains voltage. But this was less of an issue today, because you have to understand the fact that TV sets were overly expensive, bulky, and this meant that you would have a very little chance of moving one easily from one place to another. So it was a wholly different situation from today. So the TV set is powered at 220 volts. It uses two fuses at around 1.6 amps. And as you see, they are placed both on the line and the neutral. Actually, the whole case, since it's not having a transformer, could be powered. And this was, of course, an electric shock risk, but most TV sets were released like that on the market. So the experience of using a TV set was a bit different from today. So 1.6 amps. What 1.6 amps means? Let me see. I think that it's around 300 something watts. 300 something watts, yes. Believe it or not, it was a very high amount of power that was required for such TV sets operation. Of course, the fuse points at the fact of the maximum rated current that should be absorbed by the circuit. So let me see exactly, 352 watts. So 352 watts, that is a lot of power. Of course, that is the peak amount of power that could be drawn by the TV set. And let's think about what kind of consumers we have over here. We have the CRT that probably draws at least 10 watts or something in between, and a couple of other tubes. Let's see how many. I think that the count stops at 17 over here. 17 tubes. Actually, not 17 tubes, 17 filaments. Some of the tubes, as you can see over here, were combined, and this was a common practice back then because it would reduce the count of tubes and also improve reliability, because when you would replace a combined tube, you would actually replace two components, and you would have two new ones that were much better, that were having a much better performance than before. So it was a sort of early integration that was possible. Before, you would have to think that a TV set would really have 17 tube sockets. That, of course, could mean more points of failure, and the potential for let's say damage was much more increased, and of course less reliability. So you have to think about these details. So 17 tubes. 17 in the context we are seeing probably means around 15 tubes. You have to think that the picture tube is one of them. And let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, so there are 18 filaments, which means that probably either one of them is not marked on these schematics, or there is something else that creates the issue, because I see the count only getting to 17, and I'm not entirely sure which one of these is the picture tube. Could this be the picture tube, and would it have two let's say connections? I'm not entirely sure that this is the case. However, let's get back and think about another aspect. All these filaments are in series. All the filaments being in series means that even a small connection issue at one of the tubes would make the whole set unable to function. This was actually the most common issue you would have, a connection that was not good in a socket. Before we are talking about component failures, this was the most likely. Of course, if the TV set was new, this was less likely of a concern. And probably the first thing that would fail would be an electronic tube or a valve that was highly stressed, and there were such components on the circuit. The most obvious one would be the component that drives the picture tube, and this meant that such issues were much more obvious in these instances, but there were others that could fail. Another potential issue was, of course, a contact that would not be that well done, and it would mean that one of the tubes would not be operating properly. Then another detail or another issue that could be seen was the fact that capacitors would fail, and there were a lot of capacitors. Some of them were built using a very reliable technology, like having ceramics, but they could be available only in certain values. So probably something that was around a value of 470 picofarads could be a capacitor that was made was a ceramic disc capacitor, which would have a reliability that would actually be much beyond the TV set. So probably 40-50 years in the future, such a capacitor could still be working. And there were others that would fail a lot quicker, like capacitors, electrolytic capacitors, 50 microfarads at 20 volts, 220 volts, 50 microfarads. Yes, these ones could fail, and the way in which they failed could affect the circuit in different ways. Resistors failed only when short circuits occurred, or if they were presented with a high heat load over a very long time. So think about a couple of years, and then if heat would accumulate, that would mean that the resistor could fail. But this was again much less likely than one of the capacitors or tubes failing after 100 or so hours. So this meant that TVs had to be serviced constantly, either by the end user, and because this was a common occurrence, most TV sets were also released with schematics, which of course is unheard of today, because we don't repair our stuff, we just throw and buy a new one. Of course, it's a different perspective, because such a TV set would cost so much that replacing it with another one would mean probably much less of a concern. Such TV sets were used for 10 or even 15 years due to their costs, which for some, let's say, everyday consumer items like TV sets is not a given today. Probably some people just keep TV sets for 5 years or even less, just because they find a better replacement. Of course, this is not necessarily a rule, but I am talking about issues, potential issues. Next, I mentioned that this is the power supply input that goes to the filaments. And then looking at what happens, we have a couple of aspects that are much more obvious to me, and ones that are considerably so less obvious. First of all, when you're looking at the schematics, you have to understand what type of tube you are seeing, and due to the tube you are seeing and their placement, you can roughly guess at the age of a TV set and some sort of problems. For instance, in this case, you're going to notice some diodes. Of course, a diode could be replaced with just a single component, a silicon diode, but high power operation and high voltage operation was not possible with early semiconductors. So even if some of them are being present over here, they are germanium, and they can carry only very small amounts of currents. But you have to think that TV sets that were built even before that, so probably in the late 50s, didn't have even these components available. So the tube count was even higher, probably around 20 or so, which meant less reliability and more issues. So you have diodes. Probably one of them is being used in order to rectify the mains voltage and provide the plate or the anode voltage. I assume that this might be the one, but of course the way in which the schematics is being laid out is totally different from more recent models, because those models had also a different layout, meaning that what pertains to the mains voltage input and the part that delivers the initial voltages for the anode in various parts, or even for the other components, is placed on the left side. And on the right side, you have generally components that are used in order to drive the speaker, or in this case the cathode ray tube. So actually the end result of all the processing that occurs in the TV set. However, what is also interesting in this case, and I would like to show, over here you have a switcher that has various positions, and you can press for musics, speech, I don't know, probably contrast settings, automatic frequency tracking, and automatic lines. I don't know exactly what they are doing. But what is interesting in this case, some TV sets had also a way to deliver better sound, and this meant that there was some sort of equalization being done in the circuit, and this was a preset in order to achieve something. Why I presented you this switch? Not because you have this option, but because some TV sets also incorporated a radio receiver. Of course, this is not the case here, but you have to think that there were some TV sets that had this function, and it was important to understand that the TV and the radio were the centerpiece of your living room or your house, and having such a device was, of course, a major achievement. Next, I can reliably say that around this part you have some components that are being used in order to amplify and then probably make some processing regarding the signal. On the left side, you can see the input for the antenna. Of course, this was an unbalanced antenna, and this was typical back then, because the TV sets could not be connected to a cable TV system or another sort of image delivery back then. So having an aerial, as it was commonly known, was very common. Next, you would have some sort of ways of connecting the input and making some sort of impedance adaptation, and this transformer probably has this purpose. Then you would certainly have an amplifier and some sort of processing that probably would be for I think that around this area there is a tuner. I'm not entirely sure, but this is the way in which most devices were being designed. Then it says image register, so probably this means that there is some image processing happening over here, probably decoding the image out of the initial signal. And then you have other components that make various processing. I don't know exactly what they are doing, but I'm just presenting to you these details in order to understand that there was a lot being done in order to create an image on the CRT. And if I'm looking over here, there are other components that probably end up making the audio output. So high frequency yes, high frequency, let's say, settings. And you can also see, probably this is the power amplifier, because again you have to go back and forth to understand some things. This is the power amplifier that gets to an output transformer in order to drive the speaker. This was common because most TV sets did not have the ability to directly connect a speaker, a low impedance speaker that also was of course cheaper to make on the circuit directly. And you would have to use an impedance transformer, an impedance adapter, in order to have the output of the electronic tube drive the speaker, because it would have a very high voltage but a very low current, and the speaker was a device that required high currents and low voltage. And of course those are probably tweeters, which would mean high frequency speakers, and they would be driven again through some coils so that they would be better adapted in terms of impedance to the circuit. If impedance matching is not being done, the tube may be damaged, because it would have to overcome the requirement for delivering a high current. And a high current in this case would mean probably a situation that would resemble closely a short circuit, and then it would damage the tube. And in this area, line frequency, because you would have to drive a deflection coil. I'm not entirely sure where the deflection coil is being driven. I assume it's somewhere around this area. I'm not even entirely sure if this is an electrostatic or magnetic deflection CRT. You have to think that the technology back then required picture tubes to have a way of deflecting the raster and control the beam, because an image is actually composed of a set of lines that is being traced by the electronic tube. So there is a beam that has to be moved constantly on the screen every 50 or 60 cycles in order to create the image. And when the image is being created, of course it relies on the persistence of a powder that is being placed on the inside of the tube to have an emission. And due to this persistence, you will never see the actual tracing, and you would see an image that would survive at the same intensity for a fractions of a second. And this would mean that the picture could be seen on the screen reliably. And in order to achieve that, you would have to deflect the beam horizontally and vertically as well. And of course, when you reach the end of a line, you have to extinguish the beam, and you would have to make it get back to the next line. And since we are talking about interlacing, this would mean that you would first trace the even, I may be wrong, but it doesn't matter too much, the even line, so 1, 3, 7, 9, and then you would trace the odd, no, exactly the opposite. You would trace the odd lines first and then the even one, 2, 4, 6, 8. And due to the persistence of the emission powder, you would see an image that would be somewhat stable, and this would mean that you could be able to see the what you had in front of you. Let's move further and mention other details that are quite interesting. In electronic tube sets, you would have to contend with very large voltages. You have to think that just about any tube requires at least 100 volts on the plate. Some of them require 200 volts or 300 volts. And generally, in order to have a good way of diagnosing the TV set, you would have to measure the value of specific voltages and see some waveforms as is presented on the right side. This would mean that probably you would need to have an oscilloscope. This was a very expensive equipment, in some cases just as expensive as a TV set or even more. But some hobbyists or persons that were working in the electronic industry had these devices in order to diagnose what was happening in the TV set and make it work again. Of course, most people didn't have these means, and they would have to contend with having spare parts like electronic tubes, and at most have a voltmeter that would help them make some very basic determinations on what happens. So for instance, you would never be able to see these waveforms, but you could try and make some measurements for particular voltages. It would be better if you would have these measurements being done initially, because then you would understand what happens to drift. Because if some value is going to drift, I don't know, the plate voltage for tubes would drift from around 300 in this area to around 200, you would probably guess that there is an issue with the rectifier. If the voltage would be very high on another area, I don't know, for a grid, it would get from around 0 volts, which would mean that the grid would not have any sort of effect. It would get to a couple of volts, and then you would understand if that value happens to be in a certain band that the TV could be behaving as expected. Of course, things were much more difficult, because the moment you're going to be tuned on a particular station, of course, voltages would drift. You would have a particular image, voltages would drift. But in general, measuring plate voltage in various areas and grid voltage in on specific tubes would show you quite a good image of the TV's operation. Some voltages were low, like I mentioned, 72 volts, 23 volts. In general, those voltages are not the ones used on grids. So actually, you have to understand the grid as the base of a transistor. If you understand what happens, just as similarly, a grid would make the electrons flow from the cathode to the plate, to the anode. If the voltage on the grid was changed very quickly, it would modulate the flux of electrons on the anode, and this would mean that you could probably amplify a signal or make various other processing in the case of tubes like this one that have other grids as well with a different function, in order to better control the beam that is being sent from the cathode to the anode. But what matters is that most of these tubes could be tested in some ways when they were operating. And having a way to measure the current between cathode and anode was very important. There were some devices like cathometers or tube testers that were able to test a tube and see reliably if the tube is operating properly or not. But this would be in most cases static testing, which would not point at problems that would occur at high frequency, as was the case with some of these tubes that were operating in order to generate the image. So many times testing a tube was good as an initial assessment, but replacing tubes, known good tubes, with worn out tubes was a way to have a better assessment of a TV situation. So you would end up probably with a lot of components if you had the hobby of trying to repair your TV set. And of course, there are many things that you would have to take into account when using such old technology. Of course, back then it was new; you would have very little choice. What also is important was the socket. You would have sockets for the tubes, and those sockets would be mentioned on the schematic. This is the back side, and it shows the tube socket. Some of them were bigger, some of them were smaller. In general, smaller ones also pertain to smaller tubes. You would have to understand where you would have to check various voltages, but you also have to understand why things may happen that way. And in some cases, a wrong voltage may be set by a capacitor that went open, and in that case it would not regulate the voltage, or it may be a more or less shorted capacitor that would send a DC current instead of blocking it and letting only the AC, the alternative current, to pass. And there were very many details that were particular to a schematic, and in general you would never have enough information pertaining to how a particular part of the TV set operated. So this meant that you would have to understand your set as time went on and as you would see various components failing. Of course, if you would have an university degree in electronics, or you would have other sort of experience that would help you better understand what happens in a circuit, which of course was a major advantage, then you would probably guess where issues would happen. You have to understand also that various components would be quite hard to find, capacitors, resistors. There were not many shops that would carry them, but later on it was possible to find them and order or buy them directly, and you could make some attempts at restoring your TV to make it work again. And this meant that it was possible to have some sort of servicing. But of course it was not cheap, and you have to think that some tubes were much more readily available and much less expensive, but ones that were having high current carrying capacity, and this meant probably one that would drive the CRT, they were much more expensive. And another component that would many times fail would be the high voltage transformer. And the high voltage transformer, which I'm not sure if this is the one. But if it says line frequency, I'm expecting it to be roughly in this area. PL36, yes, PL36. PL36 was a known high power tube, and I can clearly estimate, let's see, PL36 or T16. Yes, I was trying to look on this schematic and notice where T16 is being placed, but I think the way in which, this might actually be for a different, yes, it's for a different TV set, so sorry, this is not this is not what I should have been looking at. This is, sorry, we make mistakes, but this is common. Let's see, PL36 must be near the high voltage output PL36 form. I'm not seeing the socket. In this case, probably the socket was placed immediately before the flyback, and possibly it could be assembled with it, and this is why we are not seeing on the main board. This was a common practice because the high voltage driving tube, the high voltage and current driving tube, the final pentode, was requiring quite a high voltage and was passing quite high currents. In this case, closely coupling it with the flyback was probably the best choice. This is not the flyback. Actually, the flyback would look totally different. It would be like a coil that is placed around an inner core made out of ferrite. And the device that would look like, let's say, I'm trying to think about a way to convey it, it doesn't matter. That high voltage that was being created by the line transformer would be sent to a diode, rectifying, not, yes, a diode. I don't know if this is the one, and then it would drive the tube, probably sending around a couple 100 volts. I don't know exactly if it's almost 300, 500 volts or around 1000. I don't remember exactly, because you have to think about the fact that all those TV sets had different specifications, and most of this information is not readily available. Let's see if there is a mention over here about the voltage. Voltage was also mentioned in various parts of the circuit, and this would help you better track the operation. So 180 volts or something like that, 210 volts. But on this side, brightness, contrast, 150 volts, 1 megohm, so probably quite a high voltage over here. 180, not particularly high. You also have to understand the fact that the voltage, that the pulses that were being sent to the screen actually could not be directly measured, because most voltmeters were not able to measure voltages beyond a couple hundred of volts or 320 volts. I'm pretty sure voltages are higher, and the voltage that is being sent to the picture tube is probably in the thousands of volts, but there is no mention over here. So many schematics were never detailed enough in order to make a good assessment of let's say the operation, but ultimately this is what you would have to contend with. I thought about having a bit more brightness. So this is what you would have to contend with. And actually it was much more complex than that. Probably I would have been only partially able to understand what happens on such a schematic, and if I would have a new TV set and then see it gradually fading, probably I could understand some issues. For instance, that some tubes would wear faster than others, and what sort of impact a tube failing would have on the output image. In general, as I mentioned, there were tubes that would fail much quicker because they were driven harder. So for instance, the final pentode would have the highest impact on the picture, because it would actually drive the beam on the screen. And there were others like audio output tubes that could fail could be quite worn and still would deliver adequate results. And of course others that would fail gradually like rectifiers without having a very large impact on what was happening. However, I should have started by saying one very important aspect. What kind of TV set we are looking at? We have very, let's say, major hurdles in trying to identify what kind of schematics it is. And of course, since I'm not all that knowledgeable, I would base my assumptions on some very small details. You have to think about tube notations, and I should have started by saying that. And all of these are the Philips identifying system, which would mean probably PY88, diode, but I don't know exactly. PL, I'm entirely sure it's a pentode. And tubes that are combined are like this, are having a free letter, PCF82. The way in which they are identified changed over time as Philips delivered improved versions of those tubes, and this meant that most of them had some sort of schematics improvement. So this is clearly a design made by Philips. I don't know exactly what kind of design, but it was certainly a Philips design. Were they good or bad? Well, in general, you have to think about a couple of aspects. The design may be very good, but if some components are having very poor performance, the TV set may not be stable, may not deliver a high quality image. So, and of course, the way in which various tubes failed, because they would probably not be available from a first, let's say, source manufacturer. I mean, the first tire manufacturer like Philips, they would probably be available from Tunsgram or another manufacturer. And this would mean that the process of manufacturing could have an impact on the performance of certain tubes. And this was particularly important for the tuner part, for any sort of image processing, and much less important for audio decoding or for, let's say, use as a rectifier. In general, tubes that were required to be operated at high frequency and delivering an image at a couple of megahertz clearly was a high frequency situation, would mean that probably they would have to be very stable and have a very good operation, which was not a given. But as I said, probably due to experience you would clearly understand what happens. And of course, I would like to mention one other common aspect that you may not be thinking, or you would be thinking if probably you would have known and experienced picture tubes. Some of the parts that were on these schematics had to be powered at high voltage, so around 7 kilovolts, 7,000 volts, or 10,000 volts, or even more like 12 or 15 would have to be delivered to the CRT. And this voltage was dependent on the size of the picture tube, because you would have to accelerate so much the electrons being released on the cathode in order to reach the front emissive side. And this would mean that having a higher voltage would mean higher stress on the components that were driving the picture tube. And this was one of the common reasons why certain TV sets were particularly difficult to service, just because they had these requirements. But of course, again, the quality of components was essential. And a power transformer like the line transformer also had another important issue, since it was a device that had to be operated at thousands of volts. Any sort of issue with insulation would mean that probably it would be lost. And sometimes you will have to think about other aspects that would make this device break down, and it was of course another very costly computer component that would have to be replaced beyond the final pad node or the CRT. You have to think that as the tube, the picture tube, the CRT was wearing off, you would have to have some ways of improving the picture. First, you would use various settings on the TV in order to increase the brightness, increase the contrast. But as the tube was wearing off, you would have to resort to other modifications, like increasing the filament voltage in order to increase the emission of the cathode, and also increasing the acceleration voltage, so the anode voltage on the picture tube. But this would make even more overstress on the parts that had to drive the picture tube, so they would fail quicker. The transformer, since it was subjected to a higher voltage, could go short, and then it would drive a chain reaction and damage other parts. And just as well, when some of these tubes that were creating the image were processing the image in various stages, decoding and creating it, could be driven harder in order to improve the raster size. And if they were partially failing, you could force them to other settings in order to increase the vertical or the horizontal size. But this would drive the tube harder, and it would mean that it would fail. So ultimately, when something failed, it was before some sort of adjustment was being done, and it would drive harder the image on the picture tube. So this meant that there was a stable working time, and then when you would need to make some settings, you were already aware that some of these parts may be starting to fail. And sometimes you would understand that, other times you would not. In the end, however, in order to keep the television in operation, you would have to replace some parts. Unfortunately, if you were driving already harder by mistake or by choice the CRT filament, there would be very little things that could be improved on the schematics in order to have a better operation. Because ultimately a worn CRT meant that the image was already less satisfactory. And one other aspect I would like to mention, and you should be aware of, was due to heat, various components would fail a lot quicker than they would in more modern circuits. Just about any electronic tube released heat, some of them more, others less. However, heat accumulated in certain parts, and this meant that the damage being done to various components was made quicker due to this. And also the fact that due to heating and cooling cycles, some connections on the board could go bad, and soldering was not particularly great in the case of some TV sets. And this meant that you would have to have an initial assessment of what happened on the board, and still a visual inspection is the best way to start a diagnostic, because you would see burned out components, burned out traces, changed color on a particular side of the board. That would show that that part was stressed and what you would do. And later on, when you made some changes, you would easily see where you have made them, and understanding what the device was doing and how it was changing in its behavior was essential. So having a TV set back in the 60s, probably around 1962, 1964, this model is from around 1964, meant that you would have to be quite knowledgeable, and it wasn't something you would quickly get a foothold in, except when you would be doing constant work as a servicing, as an authorized servicing employee, or you would work in electronics, or you would have a very strong hobby in order to do that. And frequently, because you would not have photocopiers, you would have to trace the circuit board and then make so many let's say mentions on the schematic in order to understand where you would where it would be particularly important to look for, and what you would look for in particular places. So as said, working with a TV set was not as easy. You would have to frequently make some adjustments even when you were just switching channels, because sometimes the tuner would not be in the right position. Sometimes you would have to adjust brightness or contrast or volume much more than you would do, and even sometimes you would have to adjust to be in sync with the image, and then again you would have to do that. And some adjustments were necessary to be done some minutes after the TV set started to work, because some components would obviously, as time goes on, gradually wear, and this meant that they were less stable in a cool or in a hot state, and the changes you need to be aware of. So operating a TV set was a much more fiddling experience than we had in the last 30 or so years, because so much more components were integrated, were having much better reliability, and this meant that they failed much less so as they age. And this is a thing that matters a lot. And regarding power consumption, I mentioned 352 watts as being the top rated power. This would probably mean that a TV set was drawing at least 150 to around 200 watts. This is massive if you think about the fact that today you could have a picture, you could have a TV set with a picture size that would be, I think, around 32 inches wide, with a power consumption that is less than 70 watts or so. I think even 50 watts or even less is possible today. And with a picture tube that was certainly less than 21 inches inside, due to the electronic tubes and heating their filaments, you would draw at least 150 to 200 watts. It's massive. And you would have to think that almost all of this amount of power that is being delivered to the set will be released in its back as heat. So using a TV set had a much more important impact on your power bill back then, even if obviously electricity was so cheap before the advent of the oil crisis in the early 1970s. But this was the situation. Electronics was mostly in its infancy compared with what happened today, even if by that time it was considerably more advanced than the first radios or TVs that were being released just 2 decades prior. So all of this had to be considered, that this was the state of technology back in the early 60s, and nothing more could be done back then. Later, transistors, integrated circuits, and very large advances in technology made it possible to have the current performance that is absolutely spectacular today. You have to think that on this 21 inches picture tube, or CRT, you would have a PAL image, yes, a PAL or an NTSC, that was 552 lines or 600 lines, 625 lines. at 50 or 60 Hz. Of course, if you increase the resolution, you would have to decrease the frame rate. So this would mean that probably you would have 60 to 625 lines in Europe with a frame rate of 50, so 50 interlaced frames. That was roughly 25 full frames, not far from the cinema that was 24. And if you were on the American market, you would have the NTSC standard with probably around 500 something lines, 520, I don't know exactly, 512, and you would drive the screen at 60 Hz, so a bit faster. But ultimately, you would have an image with a resolution that was probably around 300 lines at most, and now we are having TV sets that have a resolution of around 2000 lines, and even more is possible. So 4K TV sets have 2000 lines. Think about the capability. Of course, the image is in color, it's not monochrome, as in this case it's not black and white, which means much more complexity. The image could be driven at 60 frames per second, which is massively faster than what happens over here. And moreover, the picture quality, the degrading of it due to passing through so many components is extremely reduced. It's almost perfect from the moment it's being sent to the decoding circuits on the television and the moment it is being shown on the LCD or on another screen technology. So it's massive in the sense of what happened. And you would have TV sets that would have very little damage occurring on them in 5 or 7 years or even 10 years. No damage at all. You would not require any sort of servicing in this amount of time. So it's fantastic how far we've got with electronics. And if you experience the first TV sets that had to have so much fiddling, then you would be certainly appreciating the current level of technology. And another very small aspect I would like to mention in the end is the fact that you would switch channels frequently by using a rotary switch. And this meant that you would have to use your memory, and you have to make some small adjustments where you are switching from one channel to another. So clearly it's a fantastic change from today, when we are just pressing a button and everything is set, and you are just switching to another channel using a remote control. Of course, remote controls could be adapted to these TV sets, and some TV sets had remote controls, but they were much more rudimentary. Frequently, you could not switch a channel, or if you could switch a channel, it was a much more expensive TV set. In general, American TV sets had these features. European ones, due to cost, didn't have such features. So I hope you enjoyed this video. It may have been overly complex, but I think that there was a lot to present, and thank you very much for watching.